This is an interesting one. In this one, we are going to find the rate of change for a business. So let me show you how to do that. We have our revenue function, which is 50x minus 0.5x squared. We have a cost function, which is 5x minus 10. We're looking at when we sell 35 units, and the rate of change with the units we're selling per time is 15 units per day. So the dx dt is the new variable, the new rate that we haven't had to look at before. It only adds one extra step though, so let me go ahead and show you how to do this. First, they ask us to find the rate of change of total revenue. That means we're going to find the derivative of r, but we're going to take it with respect to time instead of taking it with respect to x, okay? So let's see how that happens. Our function is 50x minus 0.5x squared. So we're finding dx dt, all right, with respect to a third variable. Just watch what happens. What's the derivative of x? The derivative of 50x is just going to be 50, but we're not finding dx dx, we're finding dx dt. So I need to add in a dx dt, like we did in this example up above when we did dp dx. Now I need to add a dx dt. Next, I need to find the rate of change with respect to here, this 0.5x squared. The 2 comes down and it'll just be x. But again, we're finding the derivative with respect to t, so I need to write dx dt. That's it. That's the whole derivative. We know what x is and we know what dx dt is, so we can just plug in those values. So this is going to just equal 50 times 15 plus, or minus, our x value, which was 35 times 15. And that's it. So 50 times 15 plus negative 35 times 15. And we get an answer of 225. So this is cool because you can find a rate that has another rate inside of it. So all we did was we took our derivative like usual, but we had to add these dx dt's. And since we knew what dx dt was, all we had to do was substitute in the value of 15, and we got it done. Rate of change of total cost. Here's our function right here, 5x minus 10. We're going to find the derivative of that with respect to t. So the derivative of that is going to be, derivative of 5x is 5, but again, we need to add our dx dt because we're taking the derivative with respect to time. The negative 10 goes away because the derivative of a constant is 0. And now that's it. You just plug in your dx dt value, which is 15 from above, and that gives us a marginal cost of $75. And then finally, the profit derivative is just equal to the revenue derivative minus the cost derivative, which is just 225 minus 75, which is just going to equal 150. So this is kind of a simplified example, but this can be done if you have a lot of different moving parts. You can see how one overriding function is the sum of the changes of all the other functions. And that can even be based on some other variable that itself is changing. And that's where the real power and flexibility of this comes in. So just remember, if you're taking a derivative with respect to time, you need to do dx dt and then just substitute those values. All right, we got one more to go. See you in the last video.